go. Okay, everybody, sorry I'm not here today. They're like working on my teeth. That's just no fun. One of my friends once say, hey, no matter how well you take care of yourself, as you get old, your teeth need to still have work. I'm like, ugh. Anyway, to math, okay? So, number one, we're on page 52, and we're going to do page 52 and 53 together. So as I do this video, if you want to pause it, just ask and we can pause the video, okay? So name that function, okay? So we're going to get some characteristics, and we're going to take a look at our function family. We're going to ask ourselves, okay, which one of these could it be? Well, all right, so for example, number one, the graph is a smooth curve. Well, I know that could be exponential, because it's shaped like that. It can also be quadratic. Because that looks like the U shape, right? So we've got these kind of looks to them. We've got, you know, linear, straight. We got exponential. We got quadratic. Absolute values like the V. Piecewise is just going to be a bunch of graphs together. So let's look at B. The graph is made up of one or more straight lines. Well, that's got to be a linear piecewise, right? C, the graph increases or decreases over the entire domain. So that's probably got to be quadratic. So it looks like this. It could also be linear absolute value. It could be this one also. The graph has an absolute max or absolute min. Same thing. It's either going to be it could be a quadratic. It could also be a absolute value. Linear absolute value. And again, if you need this pause, just ask, okay? Number two, consider the graphical description of each function. Name the possible function families, okay? The graph has an absolute minimum or absolute maximum and a smooth curve. Well, that's got to be quadratic because it's a smooth curve. So that's all it could be, is just a quadratic. It's got to be that one there, okay? The graph either increases or decreases over the entire domain and is straight. Well, that's got to be a linear, right? It's got to be linear. The graph is a smooth curve and either increases or decreases over the entire domain. That has to be exponential. The graph has either an absolute min or absolute max, has a symmetry, and it's made of two straight lines. So that's got to be our absolute value, our linear absolute value. Okay? Awesome. So we know that each family function has certain graphical behaviors, with some behaviors common among different families. So, like, note here, these two, we had two on these. We had two of these and two on these, okay? The more specific characteristics that are given, the more you can specify. So then on these, we got more specific. Like, for instance, this one had to be exponential because it decreases or increases over the entire domain. Can't be a quadratic. Okay, then over here, categorizing scenarios. You've been introduced to several function families: linear, exponential, quadratic, absolute value, linear piecewise, okay? Let's revisit the first. A picture is worth 1,000 words, okay? Picture is worth 1,000 words. Each of these scenarios in that lesson represents one of these function families. So let me go ahead. So those were all of these. Okay, you got the daredevil, something's fishy, smartphone isn't smart, can't wait to hit those slopes, it's magic, baton twirling, cold weather, jelly bean. Okay, and all of those were found way back. Way back. We did the cutout and we taped them in, right? So they're way back here, okay? They're way back here. And what we did is we talked about the graphs, okay? That's what we did. Okay, we got all these graphs. So now we're going to describe these graphs one more time. All right? So then it says describe how each scenario represents the function. Okay, so they all pass the vertical line test, right? Or every x value has exactly one y value. Okay, good. So what we want to do as our homework is to look at all of those scenarios again. And our homework then is to work on page 54 and 55 and do every one of these, okay? So I will do number one with you, so you guys understand, okay? If I remember right, this is like 1.7 seconds, and Daredevil, so we have to look back. We're going to have to look back, and it seems as if Daredevil was this one, started 100 feet, hit at 1.7 seconds. Okay, so I got to look back at the graph. Here it is, sorry. 100 feet, 1.7 seconds. So I got to put that back in, okay? 100 feet. Of course, it's in terms of time in seconds and height in feet, okay? So, real domain, the real world situation. So the domain is my x values. So I'm going to either say in words, I can say in words from 0 to 1.7 seconds. Or I like set notation, 0 is less than or equal to t for time, less than or equal to 1.7. Okay, the graph behavior, it really is a quadratic. It's just an upside down. You just don't see the other half of the graph because it doesn't really exist, okay? The graphical behavior really is a quadratic. And it decreases. It's going down. So I want you guys then for homework to go back and look at your graphs. So on something fishy, the first thing I'm going to need is my scales. So I go all the way back to something fishy. Yes, you're going to have to turn back. You're going to have to go back in the page and look at it. So something fishy is something fishy's here. So it goes 200 up there and 10 there, okay? So if I go 200 here and 10 here, that's the first thing I want to do. This is time, and this is water, gallons. First thing I'd have to do is go back and get the scales, and then I can describe my domain, and I can say it's a linear function that's decreasing. Okay, so that's your homework. Please get that done. I will see everybody on Monday.